A United States supercarrier is not merely a vessel. It is 100,000 tons of sovereign territory projecting power through nuclear propulsion. It operates as a mobile airfield, a diplomatic hammer, and the central node of the most complex integrated combat system in human history. Consequently, potential adversaries have spent decades engineering specific asymmetrical counters designed to neutralize this strategic advantage. We see the development of hypersonic glide vehicles, carrier-killer ballistic missiles like the DF-21D, and quiet diesel-electric submarines. On a strategic map, a carrier appears to be a massive, indefensible prize floating slowly in a high-contrast environment. This perception leads to a fundamental question regarding the reality of modern naval warfare and area denial operations. Why, despite the rhetoric and missile tests, has no modern power dared to execute a kinetic strike against a deployed carrier? Is the carrier actually a vulnerable sitting duck, or is it protected by a layered defense architecture that makes the attempt suicidal? We must analyze the military calculus, the political fallout, and the terrifying escalation ladder that follows such an engagement. This analysis will dismantle the physics of the kill chain and the cost of pulling the trigger. To understand the survival of a carrier, one must first respect the tyranny of distance and the absolutes of mathematics. The ocean is not a flat board. It is a chaotic, opaque void where target acquisition is the primary hurdle. An aircraft carrier is capable of sustained speeds in excess of 30 knots, covering roughly 35 miles every single hour. This mobility creates a continuous problem for an attacker known as the circle of uncertainty, which expands exponentially over time. If a sensor detects a carrier at 12 p.m., by 12:30 p.m., that ship could be anywhere within a 700 square mile box. An attack is never a single event. It is a sequential chain of custody involving detection, tracking, targeting, and engagement. Breaking any single link in this kill chain causes the entire attack sequence to fail before a weapon is launched. The adversary must first detect the object in the vastness of the Pacific or Atlantic, which is statistically improbable without persistent eyes. Once detected, the target must be identified as a carrier and not a merchant vessel, a tanker, or a decoy. Data must then be transmitted to a command node, analyzed, authorized, and relayed to a firing platform. This process induces latency, a time lag where the data becomes stale while the carrier continues to sprint. To launch a 60,000-pound aircraft, the carrier must generate its own wind over the deck, often turning aggressively into the weather. This unpredictability renders a predicted intercept point obsolete minutes after the firing coordinates are generated. A stationary target is dead, but a nuclear-powered carrier has effectively infinite range and never needs to slow down for fuel. It turns the ocean into a dynamic chessboard where the high-value piece effectively teleports between turns. Without real-time, continuous fire control quality data, a long-range missile is merely attacking an empty patch of water. The common counter-argument relies on the prevalence of orbital surveillance and satellite constellations. While satellites are potent, they are governed by orbital mechanics, not tactical convenience, creating coverage gaps. Low Earth orbit satellites move at 17,000 miles per hour, providing only a fleeting window of observation over a specific sector. Geostationary satellites sit too high for the resolution required to generate a weapons-grade lock on a moving ship. Furthermore, optical sensors are blinded by cloud cover, and synthetic aperture radar has a narrow field of view. Even if a satellite captures an image, that image must be downlinked, processed, and weaponized before the carrier moves again. To solve this, an adversary must push sensor platforms forward, maritime patrol aircraft, drones, or surfacing submarines. This necessity forces the enemy to bring their assets within the lethal envelope of the carrier strike group's defensive screen. To see the carrier clearly enough to hit it, you must enter the zone where the carrier can kill you. This creates a paradox. The closer you get to resolve the targeting ambiguity, the higher the probability of your own destruction. If an adversary manages to solve the geometry and obtain a firing solution, they immediately hit the next wall. They encounter the electromagnetic spectrum, an invisible battlefield where the carrier dominates through electronic warfare. Before a missile motor ignites, the strike group is already fighting a war at the speed of light. The primary defense is not kinetic. It is the denial of information and the injection of chaos into enemy sensors. The AN/SLQ-32 or Slick-32 serves as the fleet's primary electronic warfare suite, constantly sniffing the airwaves. Radar is effectively a flashlight in a dark room. If you turn it on, you reveal your location instantly. The moment an enemy radar creates an emission to search for the fleet, the Slick 32 detects that unique frequency. It compares the signal against a massive threat library, identifying the specific radar type and its host platform. The system determines if it is a general search radar or the terrified lock of a fire control system preparing to shoot. Once a threat is categorized, the strike group shifts from passive listening to active, high-power jamming. The ship beams concentrated energy into the enemy receiver, overwhelming the sensor with blinding noise. On the attacker's screen, the distinct radar return of the ship dissolves into a wall of static snow. But blinding the enemy is crude. The sophisticated move is to feed them false information through deception jamming. The EA-18G Growler airborne electronic attack aircraft is the apex predator of this spectral warfare. The Growler utilizes digital radio frequency memory, DRFM, to record incoming radar pulses, modify them, and transmit them back to the source. It does not simply block the signal, it clones it, creating a digital hall of mirrors that seduces the enemy's guidance logic. On the adversary's targeting display, a single ship multiplies into a ghost fleet of phantom contacts, indistinguishable from the real target. This forces the enemy fire control officer into a state of tactical paralysis, unsure if he is firing at steel or software. In the unforgiving math of hypersonic warfare, 30 seconds of hesitation allows the carrier group to move another half-mile. If a missile manages to burn through the jamming and achieve a terminal lock, the defense shifts to short-range seduction. The ship deploys the Nulka active missile decoy, a hovering rocket that projects a radar cross-section larger than the carrier itself. Missile seekers operate on binary logic, not intuition. They are programmed to hunt the brightest, most significant electromagnetic return. The Nulka lures the vampire away from the ship's hull, guiding the warhead into empty air where it detonates harmlessly. But the Pentagon does not plan for single missile engagements. It plans for the nightmare scenario of total saturation. A credible attack involves regimental strength volleys, ballistic missiles from the zenith, cruise missiles from the horizon, and torpedoes from the nadir. The enemy's objective is to deplete the strike group's vertical launch cells, overwhelming the defense with sheer volume of fire. Against this storm, human reaction time is insufficient. The Aegis combat system assumes control, automating the kill chain. This is the Steel Dome, a layered kinetic shield that processes collision geometry faster than any human operator. The defense begins hundreds of miles out, orchestrated by the E-2D Advanced Hawkeye, the quarterback of the Naval Battle Network. Following the doctrine kill the archer, not the arrow, the air wing pushes F-35Cs and Super Hornets to the outer perimeter. Long-range AIM-120D missiles are released to destroy enemy bombers and patrol aircraft before they can even release their munitions. However, ballistic threats and hypersonic glide vehicles will inevitably penetrate this outer atmospheric layer. Now the Ticonderoga-class cruisers and Arleigh Burke-class destroyers step forward to form the hard kill barrier. Through cooperative engagement capability, CEC, a destroyer can fire a missile at a target it cannot see, guided by a cruiser's radar data. VLS hatches snap open, launching the SM-3 interceptor to collide with ballistic missiles while they are still in the exosphere. Simultaneously, the SM-6 is deployed to hunt low-flying, supersonic anti-ship cruise missiles, skimming the wave tops. The sky becomes a grid of calculated violence, where computers solve intercept equations to ensure a high probability of kill. If one escort ship expends its magazine, another instantly picks up the track, maintaining a seamless wall of defensive fire. While the sky burns, a silent, claustrophobic war is being fought beneath the surface against enemy diesel-electric submarines. The strike group sanitizes the depths using MH-60R Seahawks deploying active and passive sonobuoy fields. These sensors listen for the transient acoustic signatures of hull pops, flow noise, and the opening of torpedo tubes. The most lethal asset in this domain is the Virginia-class attack submarine, acting as the carrier's unseen bodyguard. It operates with free rein to hunt and kill any subsurface contact that attempts to enter the exclusion zone. Should a threat leak through the air and subsurface screens, it enters the point defense layer, the final few miles. The evolved Sea Sparrow missile, ESSM, launches from quad packs, designed to pull 50G turns to intercept agile targets. Backing it is the Rolling Airframe Missile Ram, a supersonic interceptor that requires no radar illumination to find its kill. If the threat persists to within 2,000 meters, the Phalanx Close-In Weapon System, CIWS, automatically engages. This 20mm radar-guided Gatling gun spews tungsten penetrators at 4,500 rounds per minute, creating a wall of lead. At this range, the goal is not just detonation, but the physical shredding of the missile's airframe to reduce kinetic energy. This layered architecture means an attacker must succeed perfectly 6 times in a row, while the carrier only needs to succeed once. Yet, we must confront the reality that in war, probability eventually yields to physics, and ships do get hit. Surviving the impact is a matter of naval architecture, damage control doctrine, and the inherent toughness of American steel. A Nimitz or Ford-class carrier is designed with thousands of watertight compartments and redundant structural resilience. The flight deck is armored, and the hull is double-layered to absorb the shock of torpedo impacts and near-miss mines. But the true survivability of the vessel lies in the 5,000 sailors who are trained as firefighters first and technicians second. The legacy of the USS Forrestal and USS Stark fires has forged a damage control culture that is bordering on religious. When a warhead strikes, the crew does not abandon ship. They counter-flood, brace bulkheads, and fight the fire aggressively. Imagine the psychological impact on an enemy commander who watches a missile strike a carrier, only to see it keep steaming. The ship emerges from the smoke, blackened and scarred, but launching aircraft to deliver a retaliatory strike. You have not sunk the symbol of American power. You have merely enraged it and mobilized the entire U.S. military apparatus. A strike on a carrier is not a tactical victory. It is a strategic trigger event comparable to Pearl Harbor or 9/11. This brings us to the political dimension, the cost of the button press, and the subsequent escalation dominance. A carrier is technically a warship, but legally and politically, it is considered sovereign U.S. territory. Attacking it is not viewed as a naval engagement. It is viewed as an act of war against the homeland itself. Once that red line is crossed, the logic of diplomacy is replaced by the logic of annihilation. There are no emergency summits, no de-escalation calls, and no sternly worded statements from the State Department. The event flips a binary switch in Washington, shifting the national posture from competition to total war. The president does not need to convince Congress. The burning hull of a carrier provides a blank political check. In the initial minutes, the Pentagon operates on a worst-case assumption. This is not an accident, but a prelude. Commanders assume the strike is the opening move of a comprehensive invasion or a nuclear first strike. Consequently, the rules of engagement, ROE, change instantly from fire when fired upon to free fire. The defensive bubble around every U.S. asset expands to its maximum technical limit. Any unidentified airborne or surface contact within 500 miles is designated hostile and engaged without warning. The attacker effectively discovers they have not just damaged a boat, they have triggered a ruthless, automated immune system. The surviving elements of the strike group cease all rescue operations and transition immediately to hunter-killer status. But the true nightmare for the adversary is the realization that the United States never fights alone or with a single arm. If one carrier strike group is engaged, the global force posture pivots to create a crushing vice. Carriers stationed in Japan, the Persian Gulf, or off the U.S. West Coast immediately alter course to converge on the theater. The geometry of the battlefield shifts from a duel to a siege, with firepower arriving from multiple vectors. While the Navy tightens the noose at sea, the Air Force activates the second leg of the triad. From strategic bases in Missouri and Guam, B-2 Spirits and B-21 Raiders launch with full payloads. These stealth platforms are designed to penetrate the most dense air defense networks on Earth, unseen and unheard. Following them are waves of Tomahawk land attack missiles launched from guided missile submarines, SSGNs. An Ohio-class SSGN can ripple-fire 154 cruise missiles in minutes, delivering more firepower than an entire surface squadron. The U.S. response is not a proportional eye for an eye. It is a doctrine of overwhelming disproportionate force. The target list does not focus on the ships that fired the missiles. That is thinking too small. The U.S. targeting cycle focuses on the enemy's nervous system, their ability to see, think, and command. First, the enemy's over-the-horizon radar sites are blinded by anti-radiation missiles and cyber attacks. Then, command and control bunkers, satellite uplink stations, and data centers are vaporized by precision munitions. The objective is to sever the head from the body, leaving deployed enemy forces isolated and blind. This is battle space dominance striking at a tempo that the opposing decision-making cycle cannot match. While the enemy general is still assessing the damage from the first wave, the third wave is already impacting. Deep inland, airfields hosting the enemy's bomber regiments are cratered to prevent aircraft recovery. Fuel depots and ammunition stockpiles become priority targets, turning logistics hubs into infernos. Simultaneously, the U.S. Space Force begins the systematic dismantling of the enemy's orbital assets. Adversary satellites used for targeting are dazzled by ground-based lasers or disabled by inspector satellites. The enemy suddenly finds themselves fighting in the dark, their GPS jammed and their communications severed. Back in the ocean, the U.S. attack submarines that were protecting the carrier are unleashed from their defensive leash. They move into enemy littoral waters, mining harbors, and hunting the boomers in their bastions. The ocean floor becomes a kill box, where there are no warnings, only sudden hull implosions. The adversary realizes too late that sinking a carrier does not reduce American naval power. It unchains it. The psychological impact of this countersurge is designed to break the enemy's political will. They are forced to watch their military infrastructure being dismantled, piece by piece, hour by hour. And this kinetic violence is merely the visible half of the equation. The economic war is just beginning. The U.S. Navy holds the keys to the world's maritime choke points, the Straits of Malacca, Hormuz, and Gibraltar. With a single executive order, the global trade routes that feed the aggressor's economy are frozen. This is not a partial embargo. It is a total maritime exclusion zone enforced by the most powerful navy in history. Container ships stop arriving, oil tankers are turned back, and maritime insurance rates spike to infinity. The aggressor nation, likely dependent on energy and food imports, begins to suffocate within weeks. The war moves from the battlefield to the gas station, the supermarket, and the factory floor. Strategic reserves are drained, factories idle due to lack of parts, and the civilian population begins to feel the siege. The United States does not need to invade the enemy homeland to win. It can simply wait for the system to collapse. The attacker aimed to bleed the U.S. military, but instead, they have induced a stroke in their own economy. This level of escalation dominance forces the enemy into an impossible strategic dilemma. To escalate against the United States is to invite the wrath of a global security architecture that spans both hemispheres. A carrier strike group does not operate in a vacuum. It is the physical anchor of treaties linking Tokyo, Seoul, Canberra, and London. An attack on a U.S. capital ship triggers Article 5 of NATO and similar mutual defense pacts across the Pacific. The aggressor suddenly finds themselves at war not just with Washington, but with the combined GDP and military-industrial capacity of the G7. Royal Navy attack submarines, Japanese destroyers, and Australian air assets integrate seamlessly into the American battle network. Diplomatic isolation becomes absolute as the aggressor state is pariah-listed, severed from SWIFT, and air-gapped from the global internet. This is the force multiplier effect. The realization that the enemy is fighting an economic and military hydra. But beyond the conventional onslaught, there hangs the darkest shadow of all, the nuclear threshold. American doctrine regarding the defense of its carriers against existential threats contains a calculated ambiguity. If an enemy uses a tactical nuclear weapon to sink a carrier, the response will not be restricted to conventional munitions. The United States maintains a launch-on-warning posture and a flexible deterrent option that includes low-yield tactical warheads. This uncertainty is the ultimate psychological weapon. The enemy command can never be certain where the escalation ladder ends. Does the destruction of a carrier warrant a nuclear response against a naval base, a command bunker, or a city? The mere existence of that question forces rational actors to freeze, paralyzed by the prospect of total annihilation. Therefore, the conclusion of this analysis moves beyond the technical specifications of missiles and radars. The relevant question is not, can you hit a carrier? The physics say yes, with enough luck and saturation. The real question, the one that keeps chiefs of staff awake at night, is can we survive the aftermath of hitting it? This brings us to the concept of strategic debt, the price a nation pays long after the smoke has cleared. The moment that button is pressed, the attacker accepts a debt that will take generations to pay off. You do not start a battle, you start a chain reaction that you immediately lose control over. The price is measured in the destruction of your own fleet, which took decades of national treasure to build. It is measured in the erasure of your economic progress, as factories burn and trade routes remain closed for years. And ultimately, it is measured in the survival of the very regime that thought the attack was a good idea. History shows that governments rarely survive the catastrophic loss of a major war against a superpower. The internal pressure from economic collapse and military humiliation creates a vacuum that leads to revolution or coup. Thus, the aircraft carrier serves its primary purpose without ever launching a single combat sortie. It is a floating fleet in being, a psychological fortress that deters aggression simply by existing. Its true armor is not the steel hull or the Aegis radar system, but the terrifying consequences of engaging it. Strategists often refer to the carrier as a lucrative target, but in reality, it is a poisoned pawn. Taking the piece might feel like a tactical victory, but it guarantees you lose the game. This is why, despite the proliferation of carrier-killer missiles, the oceans remain dominated by US flat tops. The gap between hit and sink is a technical challenge. The gap between sink and win is an impossible chasm. Let us recap the layers of failure an attacker must navigate to achieve this Pyrrhic victory. First, the intelligence failure, the inability to maintain a continuous track on a moving target in a massive ocean. Second, the electronic failure, the jamming and deception that turns billion-dollar missiles into confused junk. Third, the kinetic failure, the inability to penetrate the hard-kill dense layer of the steel dome. Fourth, the resilience failure, the ship's refusal to sink due to superior damage control and compartmentalization. And finally, the strategic failure, the total destruction of the attacker's nation in the subsequent counterstrike. Modern warfare is often discussed in terms of hypersonics and AI, but the fundamentals remain human. It is a contest of wills, and the will to sacrifice everything for a single ship is a price few can pay. The US Navy understands this calculus better than anyone, which is why they continue to build these leviathans. They are not building targets. They are building 100,000-ton diplomatic statements that say do not touch. As we look to the future of naval warfare, the carrier is evolving, not dying. The integration of unmanned wingmen, directed energy weapons, and quantum computing will only harden the shield. The circle of uncertainty will grow larger with stealthier ships, and the steel dome will get sharper with lasers. Critics who call the carrier obsolete are confusing vulnerability with obsolescence. A tank is vulnerable to a mine, an infantryman to a bullet, and a satellite to a laser, yet we still use them. Vulnerability is a risk to be managed, not a reason to abandon the most potent power projection tool ever devised. So, the next time you see a headline about a new missile that renders the US Navy obsolete, look deeper. Look at the geography, look at the physics, and most importantly, look at the political price tag. To fully understand the staying power of the carrier, we must look beyond the hull and look at the air wing of the future. Critics often prepare for the last war, but the US Navy is actively engineering the architecture for the next one. The Gerald R. Ford class is not just a replacement for the Nimitz, it is a power plant designed for weapons that don't exist yet. The ship generates 250% more electricity than its predecessor, a surplus intended for one specific purpose: directed energy weapons. In the near future, the Phalanx Gatling gun will be supplemented or replaced by high-energy lasers like the Helios system. A laser does not run out of ammunition. As long as the nuclear reactors hum, the ship has an infinite magazine of light-speed interceptors. This fundamentally breaks the cost-exchange ratio that currently favors the attacker's cheap drones and missiles. Furthermore, the carrier air wing is undergoing its most radical transformation since the introduction of the jet engine. The introduction of the MQ-25 Stingray, an unmanned aerial refueler, extends the strike range of the fleet by hundreds of miles. This allows the carrier to stand off even further from enemy shores, keeping the hull safe while projecting power deep inland. Following this is the air combat evolution and the concept of the loyal wingman. Future piloted fighters like the F/A-XX will not fly alone. They will act as quarterbacks controlling swarms of semi-autonomous drones. These drone swarms can jam enemy radar, act as decoys, or deliver ordnance, creating a threat cloud that is impossible to defend against. The carrier is evolving from a floating airport into a hive mother, a central node for thousands of distributed robotic assets. This aligns with the Navy's new doctrine of distributed maritime operations, DMO. The goal is to spread the firepower across a vast area so that no single lucky hit can cripple the fleet's offensive capacity. The carrier remains the centerpiece, but it is supported by unmanned surface vessels and robotic submarines scouting ahead. This network-centric warfare ensures that the US Navy sees first, shoots first, and reloads faster. So, is the aircraft carrier obsolete? Only if you think a mobile, nuclear-powered, sovereign airbase is a bad idea. History is littered with predictions of the carrier's demise. Yet it remains the first question a president asks: where are the carriers? Until humanity invents a teleporter, the ability to park a piece of the United States off someone's coast is irreplaceable. The carrier survives because it adapts. It changes its skin, its weapons, and its tactics to match the threat. It is a symbol of American resolve that is written in steel and powered by the atom. Attacking it remains a theoretical possibility for our enemies, but a suicidal reality for their regimes. The ocean is vast, the physics are unforgiving, and the price of miscalculation is absolute. In the game of global power, the aircraft carrier is still the queen on the board. It can move in any direction. It projects power across the entire map, and losing it usually means the game is over. But unlike chess, this game involves real lives, real economies, and the fate of nations. That is why the Steel Dome exists, why the sailors train, and why the reactors never stop running. To ensure that the floating prize remains the most dangerous 4.5 acres of sovereign territory on Earth. This analysis has broken down the kill chain, the defenses, the retaliation, and the future. The conclusion is clear. The U.S. aircraft carrier is not a target, it is a warning. A warning that the United States has the reach, the power, and the will to defend its interests anywhere, anytime. Thank you for watching this deep dive into the mechanics of modern naval warfare. If you enjoyed this breakdown of physics, engineering, and strategy, make sure to subscribe. We will continue to explore the intersection of future technology and geopolitical reality in upcoming episodes. Next time, we will analyze the counterforce, the rise of hypersonic glide vehicles, and the physics of intercepting them. Until then, remember, in the world of defense, what you see is only the surface. The real war happens in the invisible spectrum. This is Future War Tech, signing off.